Hi, today I will be testing a kitchen and specifically on carbon monoxide from the stove. I will check if how efficient is the exhaust fan from the kitchen is in removing this carbon monoxide. I will be using a Solidworks flow simulation. Now we will open Solidworks. As you can see, this is the kitchen. So this is the this is a window. This is an open window. Think of it as like an open window where the air from outside can go in, and then this is the exhaust hood. You can see the speed of the exhaust is 12 meter per second. This is the outlet velocity, and then I also have this stove. Actually, this is a stove. This stove produces like 3.65 kilogram per second of carbon monoxide or CO. Usually, carbon monoxide, we can find this from fumes, from burned fuel, small engines, stoves, lanterns, grills, fireplaces, gas ranges, and furnaces. Actually, this is a poisonous gases are harmful if it's not. This study is I am testing how efficient is this exhaust hood in removing this contaminant gas with this carbon monoxide. You see my study. I open my project settings. You see I used gravity in the negative y direction as usual. I'm using the internal type study, and in my fluids I'm using air, and in my wall conditions I'm using adiabatic wall, and in my initial I only change this the initial thermodynamics or the environment temperature inside the kitchen. I change this to 30 degrees Celsius since it will be hot because you're inside the kitchen, you're cooking or something like that. And then if you will go to the calculations control options, actually the project is a transient study. It is a transient with 20 seconds duration. And if you can see, I also enabled the periodic saving every one. And then this is the boundary parameters, as you can see. The environment, this is the window, as I said earlier. And this one is the exhaust fan. And actually, I already ran this project. I already solved this project. It takes like 30 minutes to solve this project. And as you can see, we will open this cut plot. I will show you this cut plot, and I will use this probe. See the mass fraction of the carbon monoxide. This is the mass fraction. You can see in the right side area here in the right side. This is where most of the carbon monoxide is located, as you see. And uh, I will run this mass fraction for flow trajectories for you to see better. See, this is how the wind flows. So the wind from outside enters from the window, and then most of the carbon monoxide is in this side. See, it's most in this side. So this is efficient, as you can see. I will clear this out for you to be. And if you will see, I will actually I already opened this one. You see, this is where most of the mass fraction of carbon monoxide is located. This is how it goes. As you see, so it is also better. So it's effective in removing. You see, the source is very high as it at this one as it emits, and then the farther it goes, it becomes less. So because of this exhaust, this is effective. You can see it eliminates effectively the carbon monoxide because from burning gas or stoves, you're emitting a carbon monoxide, and that is dangerous to the health. And at least this one is good. The system is good. You can see even at the last at the 20 seconds time, it eliminates carbon monoxide very good. See, now I will close this and we will check. I will also close this and we will check in the summary. As you can see, we will go to the tracer. This one I also used the tracer study. I used this one, you see. This one I used, this is the stove. I used carbon monoxide with the parameter with the mass flow of 3.65 kilogram per second. This one is as a tracer study, but you need to solve the main study first. This one, the main study, before solving the tracer study. And then, as you can see, we will look. I will see in the summary. You can see, meaning this system is very good. The system is very good in removing this carbon monoxide immediately. As you see, the contaminant removal effectiveness of carbon monoxide is 2.4. This meaning this is very good. As you can see, uh, a CRE result of 0 is a perfect system. CRE result of 1 is a good system, and more than 1 is even better, and less than 1 is not good system. So that's how it is. And thank you for watching.